Good morning, Honors Geometry, Period 1 and Period 5 Honors Geometry students. This morning we're going to start our new chapter, Chapter 10. We're going to go over Lesson 10.1, use properties of tangents. So we're going to start with some vocabulary that relates to the circle. Some of this vocabulary you may already be familiar with, some of it might be new to you. So I have copied the circles that show on page 641 with some of their parts labeled. So first we're going to notice that we have on the left a circle with its center noted. You're probably already familiar with a radius and a diameter. A chord might be a new piece of vocabulary for you. So a circle, definition, set of all points equidistant from a point called the center. A chord will be a line segment whose endpoints are on the circle. So start at a point on a circle and draw a line segment inside of the circle until it touches another point on the circle and you have a chord. Radius will be a line segment whose endpoints are any point on a circle. Then a diameter will be twice a radius, of course. A diameter will be a chord that contains the center of the circle. So our new information might actually come from the right-hand diagram where we're talking about a line called a secant and a tangent line. A secant, it will be a line that intersects a circle at 2 points. And you see a line that is kind of running through a circle and cutting it off at 2 points. So secant will be that line that intersects the circle at 2 points. If that secant does not extend beyond the circle and stays within the circle, it actually would be called a chord, as you see on the left-hand side. A tangent, which we're going to be spending a lot of time working some problems based on tangents. A tangent is a line that intersects or touches the circle in exactly 1 point. Make sure that you have those definitions on your paperwork and make sure you've drawn the pictures so you have a good understanding of the vocabulary as we begin working some problems. Example 1, we're just going to be practicing with some vocabulary words here, so the diagram on the right will relate to all of the problems in example 1 and guided practice 1. So we're going to use our circle vocabulary to describe line segment AC. We'll call that a radius since it is a segment that extends from the center of the circle to a point on the circle. Line segment AB will be the diameter, and that is a special chord that extends from a point on one side of the circle through the center to a point on the opposite side of the circle. Ray DE, we know that's a ray because of the symbol above those two letters. Ray DE will be a tangent ray because ray DE touches the circle at point B. So we have a tangent ray for ray DE. And then the line AE will be a secant. It is a line that passes through 2 points on the circle. Guided practice 1 asks you to name what line segment AG is, and AG will be a chord. It's a segment whose endpoints are on the circle. CB will be a radius, so that's line segment CB. It's the radius, or it's one of the radiuses that you can see on the circle. Continuing on now with guided practice 2, we're going to still use that same diagram. Name a tangent, so go back to the circle. One of the tangents that we can name will be line DE. Not the only tangent possible to name, but certainly a good one. And then we're going to name a tangent segment, and there's lots of possibilities. I've actually listed 2 here, line segment DB or line segment BE, and we're not limited to those 2 possibilities, but those both are tangent line segments to circle C. Now I would like you to make sure that you have the theorems 10.1 and 10.2 recorded in your lesson. They will be important ideas that we'll use to begin solving some problems in the next part of our guided practice. So theorem 10.1 says line M is tangent to circle Q if and only if line M is perpendicular to line segment QP. So for a line to be tangent to a circle, it does have to be perpendicular to the radius whose endpoint is on that tangent. Otherwise, if that were not the case, that tangent line would actually be passing through the circle at 2 points. So a tangent line will always be perpendicular to the radius whose endpoint is on that tangent. Theorem 10.2 gives the relationship between tangent line segments that form a common point external to the circle. So in this case, if SR and ST are tangent segments, then line segment SR is congruent to line segment ST. We'll be using that relationship to solve some problems in the next few guided practice problems. All right, so here we're going to finish up now with some guided practice problems using the ideas that we were just presented with. The question is line segment DE tangent to circle C? If, in fact, line segment DE is tangent, that would mean that there is a right angle that is formed. The angle CDE would have to be a right angle if, in fact, line segment DE is tangent. So what we're going to do is we're going to use the Pythagorean theorem on that possible right triangle to see if, in fact, it's true. If it is, we're going to know that line segment DE is, in fact, tangent to circle C. Please note, I have drawn a blue line segment to note the two places where we see a radius on that triangle. So from C, the center, through the circle all the way to E, you will see from C to the circle the number 3 written in because it's a radius. And then from the circle itself all the way out to E, you'll see 2. So from C to E, that's a total of 5 units. We need to put the radius segment together with that segment outside of the circle to notice that that line segment CE is actually 5 units. So let's go ahead and use our Pythagorean theorem. We're going to ask the question, are those two legs measuring 3 and 4 units long, squared and added, equal to the hypotenuse, which is 3 plus 2, so that's a total of 5. So is 3 squared plus 4 squared equal to 5 squared? We're asking the question, so notice the question marks that we have over our equal signs. Since when we work out that Pythagorean theorem, we notice the statement is true. We know for sure then that line segment DE must be tangent to circle C because it does form a right angle. All right, guided practice 8. Guided practice 8, we are asking the question, what is the length of the radius? So once again, from the center to the side of the circles, I've noted both of those segments as R because they are the radius of the circle. From the circle itself out to point T, that is 18 units. So altogether from Q to T, that line segment QT, the length will be R plus 18. So now we're going to go ahead and use the Pythagorean theorem. Since we do know we have a tangent line segment, it must be true that a right triangle has been formed. So we are going to say that the two legs, R squared plus 24 squared, must be equal to the hypotenuse squared. That's R plus 18 quantity squared. We're going to go ahead and work that out and solve for R. We do have to remember how to multiply a binomial, how to square a binomial, and I've put that in a thinking bubble on the side, how to use FOIL. So we're multiplying R plus 18 squared, and we are writing the response down as R squared plus 36R plus 324. The 36R comes from the inside and the outside 18R plus 18R. Then we're going to subtract R squared from both sides and subtract 324 from both sides to arrive at 252 equals 36R. Solving that for R, you can see my long division over on the side. R is 7, so our radius is 7 units long. Finishing up now, guided practice 9. This will conclude all of our guided practice problems. Guided practice 9, we're finding the value of x. We're using that theorem 10.2 that says that those segments that connect the tangent lines to an external point outside of the circle will be congruent segments, so we can state with assurance that x squared is equal to 9. Solve for x by taking the square root of both sides, and you'll get two values for x that work. X can be both positive or negative 3. All right, now it's time to go ahead and start working on your lesson for today that will be due the next time we meet. Use this guided practice section to assist you in working those problems out, and we'll see you back again for homework corrections and samples next time. All right, bye.